welcome everybody. This is my presentation about remote and online labs. My name is Paul Press. I'm an assistant lecturer at ATU Sligo campus. There's a little bit about me. I have a degree in electronic control and systems engineering, a postgraduate certificate in education for teaching physics. I spent 8 years in engineering before switching to teaching, and I've had 20 glorious years of teaching in mostly secondary schools and some further education colleges. That's six different institutions in 5 different countries across 3 different continents. So it's been a good run. COVID sort of put an end to that, and I found myself in Ireland, and I was lucky to get a job at what was then ATU Sligo, working for the iNote project on supporting remote labs, which really was a sort of 18-month role, which is just kind of coming to an end. So really, this is a reflection on that journey. So when I first started, we sat down and sort of thrashed out the ideas that were going to come to us. I won't go through the details of that, but it's sort of came out as 4 main aims. Firstly, because of COVID, there was a need to respond to lecturers, to support remote instruction, the enforced remote instruction. And secondly, we were looking to develop a central database of remote lab solutions and develop remote labs resources for online courses, and then building an international community for remote labs to try and keep that momentum going once we finished. And so initially, because we were in the throes of COVID, we sent out emails to all 3 institutions at that time, and trying to find out really what support people needed with actually taking their labs from the laboratory environment and putting them online. And it was interesting to get a number of varied responses. We didn't just get the sort of traditional science and engineering lecturers wanting support. We had people in archaeology wanting to see if they could do remote field trips and that kind of thing. So we had everything really to look at. In many cases, lecturers already had solutions. They just sort of needed either a little bit of guidance here and there on how to set things up, or really just reassurance that they were doing the right thing. And so that was sort of the initial throes as a response to COVID. And as part of that, I started setting up a database of solutions for remote lab, kind of some simulations, some videos, all kinds of different solutions to different remote lab problems, mainly in the realms of biology, chemistry, engineering, and physics. And our database currently has over 1,920 solutions in there. It's not a fancy database. It's really just a Google sheet with the solutions in that's accessed remotely. It's built on the work by Helen Reynolds, who is at the Gregory School in Arizona. She put a lot of time and effort into producing this specifically for secondary schools, and I've kind of adapted it for our needs. The biggest issue we had at the time was that from January 2021, January the 1st, 2021, Flash was no longer supported at all. So a lot of teachers and universities had put a lot of time and effort into building Flash animations to create lab simulations online. And all of a sudden, overnight, none of those worked. And so these solutions, as we sort of put them together in the database, had to be non-Flash solutions as well. So that was a sort of an interesting problem that we had to overcome. So I also created a search engine for that database. It's just a little online Unity application, and anybody can access that from anywhere, and you can search if you have a particular lab that you want to look at. I can do a quick demonstration of that if you want. And, It just takes a couple of seconds to find it and load it. So yeah, this, if you're a lecturer in physics, engineering, chemistry, biology, and you have a particular lab that you would normally do on campus, but for whatever reason, maybe you're running it as an online course, or you can't get onto campus, or your students can't get onto campus, or your students are remote, wherever, then this will allow you to search for various solutions to running that lab remotely. So you can search on various criteria. So we can go by subject. So we can go for physics, and you can go by topic or subtopic or whatever you want to do. And I want to go for any electricity, and I can put in some keywords into here. I'll just put electron in there, and I can hit search. And this will come up. This has come up with 11 different solutions, remote lab solutions. I get a little synopsis there of each one, and I can view those. So I can go and view that one online. And there we have our physics simulation. It also includes links to other search engines as well. So Merlot is one of the biggest. So if it'll put in that same search criteria and search remotely the Merlot database of solutions and pull up all the ones that are on there as well. So not only are there over 1,900 solutions within this own database, it also searches externally for further solutions as well. So that's accessible for all lecturers. It's online. There's the link here, which you'll find in the presentation handout as well at the end of this presentation. As a replacement for Flash animations, I was looking to see how I could actually create my own simulations that lecturers could use for specific applications. And eventually I sort of stumbled upon Unity, which is a gaming platform, really. But being a gaming platform, it has all the physics collisions and that kind of thing in that we might want in particularly a physics simulation. And so I set about creating a few sample simulations that we might use in a lecturing, teaching environment, with a view to really showing people what's possible, and then hoping that people will come forward and say, oh yeah, I could do with this, I could do with that. And also hoping some people might come forward and say, I want to help develop those. Because developing them is actually quite time consuming. And it's not something really that lecturers themselves would have time to do kind of as they go along. So the part of building the community of remote labs people was actually hoping that people might come on board with this and actually start generating their own Unity simulations, and we could build and grow as we went along. So this is the kind of simulation that I created on just sort of Newton's laws of physics. Just waiting for that to load. Now, as I've gone into using Unity as a platform, I found so many different things it can do. So I'll show you some bits and bobs later on. But what it's really good at is kind of the first person gaming kind of view, which in a sort of lab environment is quite fun for students. So here we have various experiments we can run. We can set our ramp at 20 degrees. We can put sensors on there. We've got a data logger, so we can actually log data and analyze that offline. We can set our experiment to run. We stop our data logger and so on. So it's really sort of trying to replicate the lab environment. We can move things around on here, so we can move our light gates, move our motion sensor, move the start point of our object, that kind of thing. But we're replicating the real sort of scientific environment. Move to a different lab. Here we have a pendulum. We can set that swinging. Or we can do a few other things. So for any physics teachers out there, sort of all things are possible here. But one of the big strengths of Unity as well is that I can actually change languages pretty simply. And so although we've done that in English, if my first language was German, I can change the language to German. Everything goes into German, including some of the instructions. So that's sort of was the initial idea, was create a couple of simulated labs, see what people thought, and I had some other ideas of creating slightly more novel ways of presenting videos even, and I found Unity could do this kind of thing pretty well. So here we are at our wastewater treatment pilot plant. We can walk through, and as we approach the video screen, then the video starts to play. Again, just demonstrating some of these things to lecturers, gave them some ideas. And that sort of brought forward a few other sort of concepts that I wanted to build in. This one in particular is a speed of sound experiment. And what I managed to do there was create a SCORM package from Unity. So not only does the simulation run online for anybody to access, it also links into to Moodle, and so we get username details. We have a little bit of integrity there in terms of who's using it, but also we can do grading, automatic grading, and those grades can feed straight into Moodle. So with our learning outcomes. So this already has data for me, so I can continue with this. And it just fires a mortar. We do some measurements on this. But the beauty of this, linking into actually what Peter was talking about in the keynote presentation this morning, you can think of this really as one of the slices of Swiss cheese, in that the data that's generated by a particular student while they're logged into Moodle on their account is unique data to them. So when they do the analysis of their data, they will get different results to any other student who's logged in. So this is kind of individualized assessment, right? But it's also, I guess, has the security of knowing that the student is logged in through Moodle. So all these kind of things are possible, and that's kind of where we were at during sort of the first year where we were mainly in lockdown. Some of these were just for demonstration purposes. So we have, if you wanted to demonstrate how a diesel engine worked, known as the Otto cycle. And this was for one of our engineering lecturers. If it'll load. One of the problems of being out in rural Mayo is we don't have the fastest of internets. No, it will load, we'll just come back to that. So the problems really with developing these Unity applications is they are very resource intensive. We have applied for a couple of funding opportunities through Unity themselves. We're looking for sort of 2 years for a dedicated programmer to help develop these resources for lecturers, really to try and create open resources for anybody around the world to use. Some of you, if you're familiar with some of these simulations, the University of Boulder, Colorado created a whole load of resources called the PhET, P-H-E-T, simulations for all kinds of different scenarios. They're freely available. Anybody can use them. Unfortunately, at the time, they created them in Flash, which they then had to go back and redo. And that's one of the other problems that we have, is actually the maintenance of these things. So it's okay creating these during a project like iNote or Higher Ed 4.0, but it's then how do we fund the maintenance of that going forward? So part of my rationale there was how do we create an international community that will support this and move it forward? So we held a remote and online labs virtual symposium back in December, and this was open to all institutions, and in fact we opened it up across the world. We had keynote speakers from the University of Sheffield and also UNED in Spain, and also we had presentations from the University of Liverpool and also the Open University in the UK. So it was open, and we had lots of speakers also from the 3 institutions that now make up the ATU. So that it was a way to sort of discuss remote labs and get this community together. But still, we're not quite there, I think, with creating a community that really wants to develop these and open them out to the world. And I think the biggest problem is going to be cost. I've continued creating these simulations going into the new year. We've got a microscopy lab that's sort of in progress at the moment, a localization lab for remote vehicles, and also a couple of sort of bespoke applications that aren't really simulations, but one as a sort of multi-screen viewer, so you can see yourself on camera while you're writing on a whiteboard, for example, that kind of thing. So it kind of shows the power of Unity. There's many different things it can do. You can create apps for mobile phones. You can create web-based apps, SCORM, that will link into Moodle, or sort of standalone packages. So I kind of went on a community building drive. Once COVID measures allowed, I managed to get across to Germany. I wrote a paper on a rationale to form a community to develop free online simulations, and presented that in Stuttgart to a community of like-minded individuals. It all went down very well, but at the end of it, everybody wants to know who's going to pay for it. And really, I think that's kind of where we're at the moment. It would be great to be able to develop a whole host of simulations, put them online, make them available to everybody across the world. But it's having the time, effort, energy, and money really to do that. That's really the main stumbling block at the moment. So that's really where we're at with remote and online labs. We've done quite a bit of support. This is all under the iNote project, which is, as we know from the iNote symposium on Tuesday, sort of coming towards the end of its lifetime. So if you have any questions, feel free to ask away. And if you don't have any questions, that's fine.
Can I ask a question, Paul?
Yes, Louise, you certainly can.
Hi, how are you?
I'm good. How are you?
Good, thank you. I really enjoyed that presentation. Thank you. Just on and I love the aspiration of trying to get as much content out there, and the willingness of all that community and the people involved. But I should say the stumbling block is the continuity after the projects have funded certain amounts of it. But just going back to the practical thing of Unity, did you find that it was a fairly easy package to learn? And do you think that lecturers can be given the tools to learn it themselves, or do you think it needs to be created for them?
I think I was actually thinking about this morning, because I mean, my role, as you know, my role under iNote was kind of unique in many ways, in that I had that freedom to create those kind of things, and that's very rare in this kind of institution. But I was thinking this morning actually that maybe another solution to that would be to have a number of lecturers in each department who can actually use Unity. I mean, I'm not a programmer, but I know a little bit about programming. I'm not a game developer, but I know a little bit about sort of 3D modeling and creating 3D engineering scenarios, I suppose. So putting that together, it took me about a month to create that first lab that you saw with the inclined plane. Not that one. I mean, that was a month of in between other little things that I was doing as well. So I don't think it's out of the realms of possibility for other lecturers to pick it up and use it. And I'm fairly certain that within the institution we teach it anyway. I'm sure there are courses in Unity from our gaming courses and things. So it could be something that it might be worth exploring. Yeah, definitely. And also for educational purposes, Unity is free to use. It doesn't cost us anything. Oh, you just muted there, sorry.
Just saying thanks for that.
Thanks. Any other questions?
You're in Galway. Very interesting presentation, and colleagues of mine teach Unity, but in reality, what you demonstrated is that, from my perspective anyway, we need somebody to be doing this full time. The concept is brilliant, okay, but like and you're a physics lecturer, so you'd be technical. Whereas if I have people in other disciplines who are no technical acumen, they'll need somebody to build this for them. So this needs to be fed into the learning technologists and the people who are running Moodle, and there needs to be some infrastructure in there that facilitates this. And this is the perfect model for it. This is exactly what we should be doing. But you need to be lecturing physics. I need to be lecturing software development. And that's basically what you should try and do with this project. That's where you should try and push it, because that's where I think it would be successful.
I agree, really. But it's I guess trying to persuade the powers that be that the funding for a position like that is worthwhile. I think. It's always a difficult one in that situation. When there are other solutions out there, I mean, something like Labster, which we do subscribe to at the Sligo campus. Labster costs around about €10,000 per year, and within that we get lots of simulations that we can use across different disciplines. And I think one of the things I was kind of trying to do was see if I could create some labs that replaced the most commonly used Labster labs. But for somebody to be sitting there in a permanent position, it's going to cost 40,000-50,000 euros a year for that salary, as opposed to 10,000 euros a year to pay for Labster simulations that are then supported elsewhere, that we don't have to worry about, that are then updated and all of that. So I think, cost wise, I think it's a balance. So it's a tricky one.